Hello, and welcome to Diesel Hub. The following is an animation provided from Ngrain through Virtual Task Trainer, VTT, to demonstrate 16 PC2.v5 main propulsion diesel engine parts and familiarization.
The Colt Pielstick High Shock Qualified Model 16 PC 2.5V marine diesel engine has 16 cylinders in a 45-degree V configuration, rated at 10,400 bhp at 520 rpm. It is a turbocharged, 4-cycle, non-reversing, clockwise or counterclockwise rotating dry sump engine. The frame consists of steel plates and forgings welded together, providing the structural support for the stationary and moving components. The main horizontal components are a lower deck and top deck. The lower deck forms the division between the crankcase and lower cylinder housing and supports the lower end of the cylinders. The top deck supports the upper end of the cylinders and camshafts. The crankcase houses the crankshaft and main bearings. Inspection covers fitted with explosion relief valves are mounted onto the crankcase sidewalls at crankshaft level. The frame is extended at the drive end to support the timing gear. The steel crankshaft is forged as a single unit. Coupling flanges are provided at each end for mounting the flywheel and vibration damper. The vibration damper is mounted on the forward flange and is geared for barring purposes. The thrust bearing and timing gear are located at the drive end flange. Balancing of the crankshaft is accomplished by counterweights mounted on the crank webs. Drilled passages are provided for the circulation of lubricating oil through the crankshaft to the pistons. Each cylinder has a cast iron liner and water jacket with watertight seals installed between them. The liner and jacket are held in place by studs that extend through the cylinder head to the lower deck. The piston assembly includes a trunk-type piston, hollow piston pin, oil tube, and rings. The top ring is used for sealing. The next three are for compression. And the bottom two rings are for oil scraping. The piston pin, which houses the oil tube, is a floating type, requiring retainer rings to secure it in the piston. The drop-forged connecting rod assembly has a shank and a cap, clamped together by 4 bolts. The crankshaft end of the connecting rod houses a steel-backed, tin-flashed copper-lead bearing. The small end of the connecting rod houses the piston pin bushing. The bearing, bushing, and rod have drilled passages to provide a path for lubricating oil from the crankshaft to the piston. Both camshafts are supported and aligned by thrust and sleeve bearings. Each camshaft consists of cams for the intake and exhaust valve push rods and fuel injection pump of each power cylinder. The push rods are actuated by roller-type cam followers that ride on the intake and exhaust cams. The push rods extend into the housing on the cylinder head that contains the rocker arm assembly. The intake valve push rod directly actuates the rocker arm for one of the two intake valves. It also actuates a partial rocker arm to the other intake valve through a pivot shaft keyed to both rocker arms. The exhaust valve push rod actuates both exhaust valves by means of a single forked rocker arm mounted on a separate shaft. The rocker arm shafts are housed in a support bolted to the top of the cylinder head. The gear train consists of two compound gear systems, each driving its respective camshaft. Both systems start with the main timing gear bolted to the crankshaft, which drives two intermediate gears, one mounted on each side. Each intermediate gear is bolted to an intermediate pinion that drives a flexible drive gear attached to the camshaft. One of the idler gears has a pinion for driving the governor and overspeed trip assembly. The barring device, mounted on the vibration damper housing, is driven by a reversible electric motor. The barring device gear drives the vibration damper to rotate the engine during maintenance. The engine can be rotated manually using a wrench on the barring device drive shaft. The cylinder head and gaskets fit securely against the top surface of the cylinder liner. Each head consists of the following parts: rocker arm assembly, two intake valve assemblies, a safety relief valve, an injection nozzle, a cylinder pressure indicator cock, an air start valve in the right-hand bank or a plug in the left-hand bank. The rocker arm assembly is composed of two units, intake and exhaust, each of which actuates two valves. The intake valves are fitted into housings and secured to the cylinder head. The intake valve seats are machined into the lower part of the head. The exhaust valves consist of independent assemblies, including the valve seat, which can be removed without removing the cylinder head. The exhaust valves are cooled by jacket water from the cylinder head. The intake and exhaust system uses two turbochargers, one for each cylinder bank, to extract energy from exhaust gases to pressurize the intake air. Air is drawn through the common filter panels, silencer, and intake shutoff valve by the turbocharger compressors. The turbocharger discharges combustion air through a seawater-cooled intercooler and air dryer to their respective cylinder intake valves. The exhaust gases are directed from each cylinder to the turbocharger turbine, where the energy of the gas is used to drive the compressor. Oil from the pump is passed through filters, strainers, and coolers before being distributed throughout the engine bearings, bushings, pistons, and shafts. A separate rocker arm lube oil system is utilized to prevent contamination of the main lube oil system if fuel oil or water leaks develop in the area of the cylinder head. It is comprised of sump tank, attached pump, standby motor-driven pump, duplex strainer, and pressure regulating valve. The fuel injection pumps are driven by the camshaft. Each injection pump measures the fuel oil into correct amounts for injection, pressurizes it, and delivers the fuel to the injection nozzles in the cylinder head. The multi-hole, water-cooled injection nozzle injects a fine spray of fuel into the cylinder. The water is routed from the header to the injector cooling water system, the turbocharger casings, and the cylinder heads and liners. Compressed air for starting the engine is supplied by the ship's high-pressure air system to the right-hand bank of cylinders. Control air used to actuate the air start control valve is routed through the barring device interlock prior to reaching the piston assembly in the control valve. Starting air is also supplied to the air start distributor for actuating the air start check valves. The air start distributor is directly driven by the front end of the right-hand bank camshaft. As the distributor rotates, it admits pilot air to each air start check valve in firing order sequence. Various engine-mounted sensors are wired to the terminal box mounted on the engine free end. These sensors include resistance temperature detectors, RTD, for each main bearing, rocker arm lube oil, and air manifold. Among the sensors that are wired to the connection box are the following: the overspeed trip indicator, the barring device interlock, the high-level rocker arm lube oil tank alarm, the high rocker arm lube oil strainer differential pressure alarm, a sensor interface is provided for the engine controller and the engineering control system, ECS, using two fuel rack proximity sensors installed and calibrated to the number 1 fuel pump rack. The inboard sensor provides a fuel rack indication signal to the engine controller. The outboard sensor provides a fuel rack indication signal to the ECS. The engine-mounted controls are pneumatic and oil pressure actuated. The Geislinger coupling is a torsional vibration damper mounted to the engine flywheel and bolted to the reduction gear high-speed input shaft. The coupling dampens harmful torsional vibrations and reduces stress on the engine crankshaft, engine gear train, and the main reduction gear.